everyone, how are we doing? It's afternoon officers. Got a little bit of food, so I'm feeling a little bit better. Whew. Long week, getting ready for the weekend. Last full week of classes. Then we got 2 days. We got 5 days. We got a week left after this. Monday, Tuesday, Wednesday. If you're here in the chat, say hey. We're just having a little bit of fun right now. It's working on some code, seeing if we can get it to do some awesome stuff. And I couldn't get the code to do what I wanted. Let's take a look. I bet somebody... maybe there is an easy code for this. I bet you I've got a package that does it. Why didn't I think of this? Let's go take a look over there. Wilson, good to see you. Wilson, put some questions in the chat. We'll get working on them. I'm looking at some regression right now, but Wilson, drop a question. Be like, hey, Brian, can you work on this? Can you talk about this? Can you talk about the project? I'm looking at some random stuff right now. We love randomness. Looking at some regression. Let me go to library, ggally. And do they have a scatter plot in here? Do they have a easy scatter plot? ggally, no statistics summarized. Ooh, there's so many things. They got facets and stuff. Maybe I'm thinking of ggpubr. You're like, what is gg? GG are the ggplot stuff. There's ggplot2. Hola, Andrew. Great to see you here. We're looking through some ggplot stuff at the moment. I know Andrew knows about some ggplots. And these are the ones right here. There is a gg scatter. Let me look at this gg scatter function right here and see what it has. Drop questions. Oh, Kayla's got some questions, and Wilson's about the project. Yeah, let's do that next right here. I'm going to finish this example up. Let me look at that gg scatter really quick and see if it works. The code says it takes data and then X and Y. Okay, so the question is, will gg scatter do what I want it to do? And it says it takes X, so it takes data. First argument is data. And so, Kayla, if you remember this right here, and then we're going to go height, weight, height not found in survey 10. Really? It says data, height, weight. 2 seconds. 2 seconds. Data X equals, wait a minute. X equals this. Y equals this. Height not found. Survey 10 has height in it. Well, here we go. Data frame. That's the MPG cars data set. Oh, it wants it in quotes. Really? Oh, hey, there we go. There it is right there. It doesn't look so pretty yet. Can we do a ggplotly on it? This is my last question of the day on this. And it looks like we can, Andrew. ggplot build is a way to make ggplot graphs. Oh, I'll have to look at that. With this right here, we can do our easy title and just do like a plus title onto it, all this good stuff. So one of the great things about this is they've really made it a lot easier since I started doing this. Adding titles and stuff to this, and you can even use the easy center title on this. So you can just center your title by going to easy center title. And these are all packages I have that do these types of things right here. Yeah, Andrew's got... I'll show this real quick, and then we'll hop into Wilson's question right here. But Andrew has this really great... These are free books. Thank you, 100 points right there, Andrew, finding all this great stuff. Showing all the different graphics and things you can do with ggplots, ggextra, and all these really cool graphics you can do pretty quickly. Or you can buy microphones and guitars. That's great stuff there, too. Let's hop back over to the main screen. Wilson was wondering about to finish the project. Can you show examples of the heading and title should look like? So you're just talking about the headings and titles? Are you just talking about like the start of it, Wilson? Are you just mentioning like the headings? I can show you how to be above and beyond. As long as you just have nice headings, you're good. You don't have to do anything too crazy. Too informal? Yeah, so what I would do is what you could do. I'll show you a trick inside of this is above and beyond right here with Brian Stevens, because what else? Come on. Let's do it. Which one let's go? Yeah, we can do a review right here, Kayla. We'll do a review next, Kayla. You got it. So with these headings right here, let's say you go and say, you know, like t-test. If you go here and copy the heading on it, and you do this for all of your stuff like to sample t-test. And then you go here and you do heading 1 on it. And you go here to like results or something like that, and you go to heading 2, and you do something like results right here, and you go to heading 2. Does this make sense what I'm doing here, Wilson, by doing the headings? Does that make sense? Like, perfect makes sense of this. This is something graders should like this. If a grader counts off, please talk to me or talk to your teacher. But I think this works really well because what's amazing about this is if you go through here and do this, you can then go in and you might have like your executive summary right here or something, but I think this is pretty important. Executive summary. And executive summary should be heading 1, future research. So we'll kind of control the size of the font too. I think it also, if you notice how it changes size. Executive summary is going to be on here. T-test is going to be here on a new page. 2-sample t-test is going to be here. Future research is going to be here. What you can now do is, I think, go to references. Where is it? We want to go to review. I think it's review. And under review, I'm looking for it. I don't do it a ton. I've done it for a few reports I've done. Oh, where is it? Table of contents is under references. So if you go to table of contents, boom. There. Oh, we don't want to put it there. Oof, don't do that. Well, you can put it after the executive summary. So maybe what you could do, depends on where you want to put it. Graders should not count off if you put your table of contents right here. There you go. What's even better, if you're inside of Word, you can actually usually click them, I believe. You should be able to click them. I thought you could. But you've got your table of contents right here, kind of going through your different segments. Kind of a neat thing to know that you can do this inside of Word. But you can also get your headings and kind of decent looking heading. Yeah, you can just put your name, put your title of the company, all that stuff right there. I'm always doing the above and beyond. So you can go right here and go to home and put like like name of company / report. Well, I wouldn't do that. You could be like, yeah, just put whatever the name of the report is. You don't have to be too, just think about how to make it look nice. The neatness, we don't, like you don't need table of contents. I like them. I have my like summer classes do table of contents, but as long as it looked nice, does that make sense? Like very few people lose points on the neatness. People lose points on neatness when they have things like way too big, way too small. You can't read the output because it's blurry. If you're taking phone pictures, don't take phone pictures. If you take phone pictures, you're going to lose points on neatness. Like if you're like, let me take a screenshot of that. No. Use Command-Shift-4 or snipping tool. Much easier to read. Exactly. As long as you're not doing anything too crazy, you won't lose points on neatness. We try to make sure those points are pretty much given to you, unless your report has issues where it's like this looks like, because there's different ways to do things. So that's what we're all about. Now then, as long as it's not too crazy, exactly. As long as you don't have to go the above and beyond, but never hurts. Let's do some. Kayla asked such a good question right here about knowing what test to use and when. Let's do some quiz time. Reviewing for the final. I'm not seeing the formula sheet. It should be up. I'm going to talk to Terry. I'm going to make sure we have it up like this week. So the review page 3 doesn't look to have up the stuff yet. I think he's making sure we have the right formula sheets. So it's not currently up, but I'll probably make a video going over it too. Yeah, we can do some. Nate put a question in the chat. We can do some chapter 17 homework. If you're like, hey, can you do this question? We're going to do a review question right now. And then you have to see if you understand which formulas to use right here. Let's go ahead and do a review question on, can you tell what to do? Drop a chapter 17 question in the chat and we will work on it. Just say like, hey, can you work this one? Can you explain how to do this one? We'll work on it. So review question. Here we go. Brian wants to find out from his students if they have started studying for the final at all. He currently believes that 50% of his students have started studying in some way. He asks 200 students if they've started studying, and 110, this is like convenience bias to the nth degree, report they have started studying. What should Brian do? This question is a little open-ended. What should Brian believe? But can you tell where this is going? What do you think this is, Kayla, and what do you think we're going to do here? Like, a lot of times in the world, you're not presented with a write out the this, do the this, which we will go through the steps of this. But we should see some values in here we are identifying. And what do you think we're going to do right here? Like, Brian has a current belief, so what do you think we got right here? Brian has a current belief. This is a good test question. It would be more specific on the test. It would probably say identify the this and identify the this. It's a hypothesis test, right? So let's identify the values first to know what we're dealing with right here. And do you see any values we know right here? What are some of these values? Very important. We know all these values and can identify them in notation because that's going to pretty much lead us to the formulas we're going to use right here. So you got it. 200 sample size. If you get one more of these, I think you'll know all the notation. If you get one more of these, I think you have all the notation. I think you'll be like, okay, now the ball just rolled downhill. So Brian currently believes 50% of his students have started studying in some way. 110, you're on the right, yes. How will that be written? Like, this is what the hurdle I want you to get to right here. I want you to see that, and that's going to be a huge deciding factor for the whole rest of this question. Basically, it's the variable type. What notation will I put for that? Like, when I write that as notation, what would I put? Not P, but because it's categorical. And Sam, 100 points, Sam. Sam, thank you for jumping in. Good, Sam, you got it. Not P. So close. So close. Not P. That's not P. It's what? It's what I currently believe. You're so close with P, though. You're so close with that. Because it is proportion. So close with P. This is the hurdle. This is the new notation. P naught. That is what I currently believe my hypothesized there. So what's the last thing? You got it. We're just getting that ball rolling down the hill. We got 110 out of the 200, which gives a hint for what it's going to be used for. 110 out of the 200 means that that's what? 110 out of the 200 is going to be what? Well, so the 110 is the what? Out of the 200, this will solve for something else. So 110 out of the 200 students. I am on top chat. I am a fool. Sam, I want to throw you another 100 points, Sam. Not the alternative. It's X. It's X. It's just how many we observe in the sample. Does that make sense? No, you're right. It's X. Don't worry. Don't worry. Just take a stab at it. Just take a stab. If you're wrong, it's no big deal. 100 point scale. Don't worry about this. Don't worry about being wrong. Just if you think it's X, just say X. You're right. It's X. It's how many successes there are, right? So what are we going to use X and N for? What will we use X and N to solve for now? I know I haven't written the questions because if you can see the questions, you can then solve these a lot quicker because you can be like, P hat, exactly. X over N equals P hat, which is the sample proportion because this is how many we see in the sample out of the total, and the sample proportion is 55%. So now that we have all of this, let's write our null hypothesis. Our null hypothesis is going to be what? That the true proportion is equal to what? Now be careful. The null hypothesis, I pause right here because this is where mistakes can happen. I'm going to do it in a different color. The null hypothesis is that the true proportion is equal to what? And then did correct P naught. Nate, did you have a specific question? Nate, drop a question on chapter 17. We'll do that coming up here next after this example. And then Brian wants to see if this is true. So I'm going to use the does not equals alternative to see if it is not this. Does that make sense? We're stating the true proportion of students who have started studying is 50%. The alternative is that it's not 50%. This is step one. So now we need to go out and find the, thank you so much. Just put the start of it. If you just put the start of it like acid rain question or something, I'll find it. If you just put the start of it like a bike route question, I'll know which one we're talking about. If you just describe it, I can usually figure out which one. So now, Kayla, we need to find the what. Step two is we actually need to run the test, or we need to look at if we have enough successes and failures. We have 110. Well, according to the null, we should have 100 successes and 100 failures. So we're good there. You got it. We'll do the fact contents. Thank you so much, Nate, right there. We'll do the fact content next here in about 3-4 minutes. You got it. So now we need to do what? What do you think? So we're not going to do a confidence interval. We're going to run the hypothesis test. So since we have a hypothesis, so we could do a confidence interval, but this is right now set up to do a hypothesis test. John, great question right there. I'm using the basic, which only has 2. You are. Great question right there, John. You are able to use the same variable twice. Good question right there. So what we're going to do right here is we're going to go p hat minus p naught over p naught q naught over n square root. Does that make sense, Kayla, on this step? Does that make sense on this step right there? Oh, yeah, no worries. I think it's better to do it live so people can practice. So don't worry. That's why you have the only next question. It's open questions right now, pretty much. Does this make sense why I'm doing this right here, Kayla? I'm finding out the what between these two numbers. They're what? I'm finding out like what I believe is true and what I saw in my sample. I'm finding the what between those numbers. So what do we do at the top of every test? We look at the what between the two things. Like, here's what I believe. Here's what I saw. I'm just finding their what. It's like, this is what I believe currently. This is what I saw. This is how far they are away. That's just the what between the two values. I'm just finding their what, their difference. And then I take that difference and I standardize it to turn it into a z-score. Does that make sense? So I'm just taking the difference, standardizing it to turn it into a z-score. So let's go here and plug in numbers now. And this just gives us like a standardized way of looking at it, hence a z-score. That's what we saw in our sample. Oh my gosh. And so 0.5 times 0.5 over 200. So let's go find the z-score for this. Calculator's all over here. 0.5 times 0.5 divided by 200 square root. And z-score is kind of interesting because we're going to get 0.5 divided by this, 1.414. It's like square root of 2, I think. Very close to it. So that right there is the z-score. The third step right now is going to be do what? Once I get the z-score, I'm going to use the z-score to find the what. Now that I have found the z-score, I'm going to use the z-score to find the what. Just, you could say one letter and I'd know what you're talking about. I'm going to use the z-score we just found to go find the what next. Now that I have the z-score will be used to find the what. We have the z-score. So now we need to figure out how likely this is. Like we know a standardized metric. We know what the z-score is. Now we're going to use the z-score to figure out how likely this is or how probable it is. So now we're going to see, was this, p-value, exactly. So the third step right here is to find the p-value. And we would go to the normal curve. So we're going to go to the David M. Lane right here. I will say this, Kayla, I'm doing this in a little more of an advanced, tougher way right now, where usually the question would prompt you, find the p-value, find the z-score. But I'm kind of, if you get this example and could walk through these steps, you have a deeper understanding of this, because then you can see like the steps as we do them. Be like, okay, now that I have the z-score, I have to get the p-value, because that's what we use the z-score, the test statistic, to find the p-value. So I'm just kind of prompting you with each next thing to see if we can figure out the next result. What do you think I should do? Remember, this was the alternative. What do you think I should do with this value right here, which we'll go show it on the screen? No, you're doing great. You're doing great. Just take those guesses and you're on track. Like, two-tailed, exactly. And I'm bringing up the David M. Lane. So we need to double it. Yep, exactly. Since it's that, we need to go over here to this other side, and we need to double whatever this is, which we can show it. So we can show graphics and stuff, and that's the negative. So this is going to be a slightly larger p-value. It's going to be between 10 and 20%, probably closer to about 14-ish%. I say 14%. And the answer is 15%. So 15% right there. 14, 15, 16. It's still what, though? The only thing that matters really right now is that it's what? This p-value right here, which we found of basically 16%, something like this, which is the p-value, the percent of area, is what right here, which is step 4. So now we're on to step 4, and we can come to our conclusion, and what? What is our conclusion right here? And then what does this mean for Brian? It's very high. Exactly. It's high. The p-value is high, so what are we going to do? Do not reject the null. So we do not reject. Put a big not reject. So we do not reject the null right here. So what does this mean for Brian? Brian is going to do what right now? Is Brian going to keep to his belief that about 50% of his students are studying? Or is he going to not believe that and say, well, it's probably something different? Remember, he saw 55% in his sample. And so this is where students get tricked usually. Brian saw 55%. So is Brian going to think, well, I guess it's more? Well, that's not even what I tested. Is Brian going to think, well, I guess it's more? What will Brian think? Brian does not have enough what? That's some me here on Pearson a lot. Brian does not have enough what right now to leave his current belief. He's going to keep his current belief, right? He's going to be like, well, I guess this 55 is just random variation. I don't have enough evidence to reject my belief exactly. It could just be random variation that is causing what we see in the sample. Like maybe it's true 50% of my students are studying. I do not have enough evidence for the alternative that the truth is different for 50%. Like, yeah, it is about 55. Like that's about 55%. Does that make sense right there, Kayla? That's about 55%. Like that's what the stats are saying to us. Like if you think about it, if I said to you, I think 50% of my students are studying, you're like, well, I saw 55% in a sample. I'm like, yes, it's possible. It's possible given 50% is true. If 50% is true, then maybe you'll see 55. That's possible. But if you had seen something like 60, and we can quickly calculate this, if you had seen 60, just think mathematically, what would happen? The most horrible 5 ever. What would happen to the p-value here if the distance up top were to double? If the distance up top were to double, what will happen to the z-score? Not the p-value yet. But if the distance up top doubled, the z-score would what? Like if 60% is what we saw in a sample. And the p-value is going to decrease. Great job answering the second question. Because the z-score is going to actually double. If you resolve this now, you'll get a double z-score. Does that make sense? It's going to double because the distance just got twice as big. So we're still standardizing by the same metric. Like this didn't change. The distance just got twice as much. So it's twice as much distance by the same standardizing factor. It's further away. And if it's further away, the probability of observing it would do what? If it's further away, the probability of observing it would be water, which you just said. I'm just having you repeat yourself at this point. If it's further away, the probability, and we really don't even need the David M. Lane at this point. If it's further away, the probability is going to be water. Exactly, Campbell. Great job right there. The p-value is going to decrease because this is less likely. Like now we're saying we saw 60% of students studying. So now this is less likely here. And Campbell, excellent work. And we would go here and put in our new, it's going to be very, very tiny, less than like 0.001 or something. It's going to be very tiny. Oh, wait, outside. There it is. Very close to 0.001. It's going to get smaller, and we're kind of doing our quick drawings of it to be like, yeah, this is very unlikely over here because I'm drawing a quick sketch of a very quick sketch. That's not where 3 is at because we're at 2.8. That's at 2.82 right here, and that's at negative 2.82. And so these would be the z-scores down here. And so now we change because our p-value is 0.0047, telling us that what we observed here, or something more extreme, is very unlikely. So now we do reject. So, and great job right here. So now we would have evidence. And this is a change to the question. I quickly changed the question to now 120 students report. So that would actually change the p-hat, which is the sample proportion. Kayla, do you feel a little bit better about this one? And there's a lot of we did a bit of conceptual stuff here too, understanding how the z and the p-value are related. And we did a good bit of notation. It's a really good kind of quick example, but understanding the notation, the steps, finding your null and alternative, running the test right here, finding the z-score, finding the p-value, rejecting or fail to reject. So this is a kind of a mini version right here. But I didn't say what the question was to begin with or any of the notations. That's kind of the key. And we could do another review question here in just a little bit. I think these are really good practice. Just to be like, what do I have? What would I use to solve this? And then thinking through the steps. And the more your brain gets in tune with that, you'll get to a question on the test, be like, oh, it's just asking this. It's just asking me to do this, this, this. We'll come back here to another one of these. I don't know. I like doing these. They're fun. We have here the hot dog question. Let's get the hot dog question going. I think it is. Nate was wondering about a study of fat content. Let's go check out a study of fat content. Assignment manager. Oh my gosh, Ma Pearson won't open. Ma Pearson is opening up. Good practice, everybody. That's what it's all about. The more problems you see, the more you practice. You might reach that point, Kayla. I had a test one time where I was like, I don't even feel like I could study for it. And when I went and took the test, I was like, yeah, I know this. I made like a 98 on the test. It was for a math class, matrix algebra. I had a Mark Bly, great teacher. I even learned a lot about teaching. I was a teacher when I took his class, but just his teaching style and everything really showed me a lot. So shout outs to Mark Bly right there. I can't remember what university he's currently at, but really great teacher. Yeah. I hope it happens to you too. I hope you're taking this and you're like, no, you'd be shocked. You'd be shocked, Kayla. I think you got it. I keep that hard work up. Semester's almost over, and then have a great winter break with the family. I mean, still enjoy yourself right now, but have a good time. Husband, kids, everyone, just have a good time. Going back in here to the main screen, doing some fat content and hot dogs. Let's do this. Here we are with a confidence interval right here. I think this is the one we're doing, right? So here we are. We're trying to estimate the difference. Now, I want you to think about what we have with the data right here. We're going to go out and we're going to collect some data on hot dogs. Who wants a hot dogs right here? But I graduated in the summer. That's awesome. Congratulations, Kayla. That's so awesome. We go right here and we go to type of hot dog. And we got the type of the hot dog, and then we got the fat content in the hot dog. So let's go right here, and we got here beef hot dogs. So here's your beef hot dogs. Beef hot dog. Really? Gotta hit it twice. Really? Computer's possessed. Sometimes you have to hit it twice, apparently. And we got here your meat hot dogs. So I want to point something out right here. I'm going to kind of replicate what I think could be going on with this data. That's probably good. The interval is positive. So I'm going to go right here and do the following. 15. I might not have enough data to make it close enough. Little variation might win the game. You're literally working at a food lab right here and collecting data. Now, I want you to notice something about this interval. And jump does reverse alphabetical. Yeah, we'll make that lower, make it easier to see. What do you notice about the fat content of the beef hot dogs versus the fat content? What do you notice right here about the fat content of these hot dogs to make it a little more obvious? What do you notice about the fat content of the meat versus the beef hot dogs? Here's how much, and we're just measuring. We're just taking these hot dogs. We sampled 15 hot dogs right here, smallish sample. Hopefully the numbers work out. But meat has higher fat content. Let's run the data. So this is how we'd run it right here. We'd go to analyze fit y by x. You don't have to do all this. I'm just doing the extra. And look at it. We do see that. Let's go to the 2-sample t-test. And I want you to notice something. Oh my gosh, we actually got super lucky. Look at my interval, like their interval. Do you see my interval is completely what? I've heard that today. I've heard campus Wi-Fi is pretty bad today. What do you notice about my interval and their interval? And it's actually kind of close. I actually did a decent job today at this, recreating some data. What do you notice about my interval right here? And look at the way the test is done. It's meat minus beef like theirs. Like theirs is meat minus beef. So my interval is completely what? Almost exactly. I was shocked actually when I saw it. I was like, should have hit that right there at the start. Very similar, but the whole interval, both numbers are what? Like it says here, the endpoints of the confidence interval, we could just use our interval right here. Rock.
It doesn't matter.
At this point, we've replicated it closely enough. Oh no. We might have to deal with that, Sam. Might have to, with assignment student, I will be sending updates maybe. So the interval is completely positive, right? The way we did this was meat minus beef, right? So the endpoints of this interval being completely positive indicates to us what? We're trying to figure out the true difference between these. Oh, no. Kayla, bye now. Great job, Kayla. Kayla's throwing in some answers. Great. Kayla, 100 points right there. See what Kayla wrote right there? She said, since the endpoints of the interval are completely positive, we're trying to estimate the difference between these hot dogs to be like, okay, this hot dog has an average somewhere in here, and this hot dog has an average here. We're interested in the differences between these averages. Does that make sense? What's your best guess of the difference between these average right here? So, Nate, what's your best guess of, and you can see it kind of visually. Do you see how far this is away? Look at the scale over here and then find a number down below. What is your best guess of the difference between the averages? 4-ish, or maybe 4.42-ish? Right here is the difference we observe between the means. Does that make sense? And then the margin of error is about 1 because it's like 4.4 plus 1, 4.4 minus 1, and that's what makes the interval. Because we're trying to say, like, what is the real difference? Nate. 4, you were good guess at the 4. I'm throwing some points out there. 4 is a very good guess, and that is the numeric difference between the two hot dogs. And the fact that the whole interval is positive is indication that the first one is higher. Now watch out, if it's negative, that is indication that the second one is higher. If it includes 0, that is indication that there might not be a difference, kind of covering other versions of the question. So it's probably higher for the meat because the interval is positive. Because remember, this is the positive number. If the interval is positive, it's probably that the first one is higher. And this is a really good replication of what the data might look like. Remember, we are food. Oh, thank you so much, Nate. I was trying to figure out some really good ways of teaching this one. Everyone's so positive today. Like, you're literally sampling these hot dogs and being like, this one had 12 grams of fat. And you can see the data right here. I think that can help sometimes to see what we're looking at. What does the fact that the constant interval does not contain 0? You think the difference is probably somewhere between meat having 3.4 to 5.4. It does not contain 0, so those results are what to you? The answer to what they are to you is right here. So those results not containing 0 are what to you? You can see the answers on the slide are on the question. Since 0 is not contained in this interval right here, what does that indicate to you about the difference? We think it's what from 0? It is significant, exactly, because 0 would be no difference. So we have statistically significant results because this is the same thing right here. It's testing to see if the difference is 0 or is not 0, this two-tailed test right here in the output. And so since 0 is not in that interval right there, we would have good reason to reject 0. So I would say there is a difference. The difference in the two is significant because 0 is not in the interval. Yeah, rockstar name. Keep it up, man. More points. And so this was tested with a 92% level of confidence. And feel free to ask another question. We got open questions after this, so knock it out of the park. Just throw another one out here and we'll do it. This was tested with 92% confidence. 92% confidence interval looks like this. Crude drawing of it. The two-tailed test would be done with a what alpha level? The two-tailed test looks like this. As a decimal, it's put in as a decimal. What would be the two-tailed test? Oh, good. Yeah. If you have another question, let me know. What would be the alpha level for the two-tailed test? So it's asking about. Sure, let's do crayon today. What is the alpha level right there? So the alpha level is the remaining outside. Yes. Did you see it, Nate? So it's going to be the total on the two-tailed test. There are ways, Caroline, great answers right there. There are ways, Caroline, throwing in some points for Caroline right there. It'd be 0.08, Nate. You are correct about 0.08. 0.08 is the total area outside. Sam, great job. Love it, everyone chiming in with these answers right here. 0.08 is the total area outside, and a confidence interval is relative. Oh, it wants as a percent, actually, so don't put it in as a decimal. 8% alpha. We don't always say alpha as a, yeah? Did you have another one you want to do? Just pick it, and we'll do it. Your call. Next question to do. Just take a pick. Good concepts. Knowing the concepts is the key to this. Like, understanding when we reject the null, understanding what alpha is. You don't want to look at this like memorizing each question. You want to be like, okay, if I'm doing a confidence roll, the associated two-tails test, because remember, confidence roll inside, two-tailed test outside, is just 1 minus confidence roll. Sugar content in cereals. Let's do some sugar content in cereals. Here we go. Cereal sugar content. Let's do it. We got some sugary cereal here because, I mean, come on. It's awesome. And so you see the same data. This is sort of the same idea of what we were doing a moment ago. And it's going to give us the data this time. We came up with hypothetical data last time. Now, something interesting is going to happen when you try to bring this data to jump. You're going to go here to this. Go a little slow right here. You're going to copy the data to the clipboard. You're going to hit Control-C or Command-C, Mac versus PC. If you see a command there on a Mac, hit Command-C. So now that you've got your data copied, please notice there are column names. It's very important when we paste this data. Go ahead and open up Jump. And inside of Jump, you're going to go to File, New Data Table. Boom! Sam knows what's up right there. Sam's done a few of those, right? 100 point Sam right there. So we're opening up the new data table. Don't click inside of it. Don't click inside of it. Everyone does that for some reason. I'll be like, ah! And then we're going to paste with column names. How much sugar is in my... Today I'm advertising for Chobani Complete Peach Yogurt. Good stuff right here. Excellent yogurt, Chobani. A lot of sugar. Love it. Something looks different. This is how the data should look. But both of these are two what columns. I just want one letter in the chat. Chobani is awesome. Chobani is top tier. So S tier Chobani is what I say. What do you notice about both these columns versus the way I want it? So this is old data, but if you've done this, you're correct, but we need to do an additional step. Both of these columns right now are what? A little bit of a problem with this data. We'll fix it up. That's categorical over here. That's quantitative by virtue of the color tells us the variable type in Jump. This is quantitative. We'll fix this up. We want them both to be, we want one to be red and one to be blue. Does that make sense, Sam? Right now it's quantitative, and this would be like paired observations on a row because we want them to be categorical quantitative. So go up here to tables. I'll pause when I do this and go to stack. There's not an error right now. Make sure that they are both supposed to be blue. If they are blue, that's good, but we're going to get the data correctly stacked. We're going to literally take these columns and stack them. So we're going to go to tables and stack. I try to pause when I'm going to click a button. We're going to go to tables and stack these columns. So we're just going to take the columns, stack and stack, just double click both of them. And that's just going to take your columns and stack them on top of each other. And then it's going to use the label of the serial as the other variable. Now that we have them stacked, let's take a look at what we get. And take a look right here. We see the same sort of idea with a 2-level categorical X. Now, why do we need a 2-level categorical X? What are we about to do? We are about to do a what t-test. We need a 2-level categorical X to do this. We're about to do a what t-test with this data we just got into Jump right here. So we need a 2-level categorical X with two groups, like adult serial, children's serial, because we're about to do a what? The whole goal of getting the 2-level categorical X to compare a quantitative variable across them. I'll pause on the next button click while we ask this question. We are trying to do a t-test, but not just a t-test, a 2-sample t-test. Does that make sense? We want to do a 2-sample t-test. So we're doing two groups. We're comparing the mean of children versus the mean of adult cereal and seeing which one has more sugar content. We'll find out it's kind of obvious. So we analyze fit y by x because we have two variables here. And we could do a two-tailed test. The tails refer to the sign of the alternative. Caroline, great answers right there. The tails refer to the sign of the alternative. The 2-sample refers to there being two groups. So you could do a 2-sample, two-tailed test. The 2-sample, two-tailed test would have two means where we're testing to see if they're not equal to. The 2 tails refers to the sign of the alternative. The 2-sample refers to two groups being tested against each other. Make sure to have those notes. And Caroline, thank you so much for all those questions and answers right there in the chat. Good practice. So we go right here and we put the label in the X and the data in the Y. So the label is what we're splitting it apart by. And then the data is the quantitative variable we're analyzing by, because we want to analyze the quantitative mean. And then we want to split it apart into two groups by the categorical label. Should be good right here. Let's go ahead and click OK. Pretty obvious to see. Great job, Caroline. Pretty obvious to see here that children's cereal has way more sugar than adult cereal. I mean, come on. And it's like you got some fiber 1 right here, and then you got like oops all berries up here for children's cereal. Maybe this is like fiber 1 with marshmallows. I don't know. Still bad. And then we click up here to the red arrow and we go to t-test. That is where we do the 2-sample t-test. It doesn't say 2-sample t-test. It just knows, Jump knows it's doing 2-sample t-test. T-test would be for one mean. So this is a 2-sample t-test because it is for two means. They just didn't call it that. There we go. Now, we're not going to use the test portion of it, but the test does come back statistically significant. We're going to use the confidence interval portion to say, I am 95% confident that what cereal has this much more, and my gosh, I love those numbers today. What cereal has how much more sugar to how much more sugar in it? I'm going to ask 2 questions on this, each worth 500 points. What cereal looks to have more sugar in it? I'm asked 3 questions. I'll throw 1,000 points if we can answer all 3 questions. Let's get this right here. What cereal looks to have more sugar in it right now from the output? Pretty obvious to see. Look at the way it looks. Got the 1,000 points loaded up to go. Crazy points here at the end of the semester. What cereal looks to have more sugar in it? Just look at the data and be like, Children's, exactly. Kind of obvious, right? And then the interval is completely positive. If you remember from that meat versus beef question, the interval is positive. So we think children's cereal has between 32 to 40 more grams of sugar in it. Great job, Josephine, right there. Excellent work. Got 1,000 bucks ready to go in a moment. What is your estimate of the true difference between the cereals? Like, what do you estimate the true difference between these cereals to be? Like, the true difference between these cereals is probably about this. Like, what's your best guess of the true difference between the cereals? What's your best guess of the true difference between the cereals? It's a big earn of 1,000 points. We're understanding how to look at this output. Like, I think the difference is probably this. I saw this in the sample. Boom, right there, Nate, just crushing. I'm throwing an extra 100 points. We got the 1,000 points ready to go, but we got a few more questions to get to it. And then what is your margin of error for your interval down here? Look at the interval and tell me the margin of error. I love these numbers because they're so nice. What is the margin of error for this interval? So the interval goes from 32 to 40. Remember, the margin of error is half the length of the interval, like 36 plus or minus this. The margin of error is half the length of the interval. Careful, careful, careful. You're thinking the whole interval, Nate. You're thinking the whole interval. You're on the right track. The margin of error is half the length of the interval because we could say 36 plus or minus this. You got it, Nate. Another 100 points. Getting close to 1,000. Last question of the day right here. Write the mathematical equation to find the t-statistic, which would tell us the standardized difference. Write the mathematical equation to find the standardized difference. Write the mathematical the equation, like plug in the numbers. I can't move this. Sure, there it is. So it's the difference over the standard error. And you can actually do this one in your head. Hence, it turns out to such a nice number. Show me with the numbers plugged in how you'd get the t ratio there, which is the difference divided by the standard error, which is how many standard errors we are away, which then we'd use that to find the p-value, which is basically 0. You can't even see the p-value on there. Last question, 1,000 points ready to go. Just show me the mathematics. Boom. Whoops, didn't hit it. Nate, amazing work, Nate. I'm throwing another 100 points on that. And so all this output right here is just to have us conclude there is good evidence that children's cereal has more sugar than adult cereal. Kind of obvious on this one. I hope, Nate, it's starting to make some more sense, but we have all the answers of 32 and 40.07. I think those are the only numbers. Watch us get it wrong now. That'd be awesome. That'd be amazing. 32 and 40.07. Those are the numbers there. And children's cereal have between this much more than adults. 32 and 40.07. How's it, Nate? Great job on those points right there. Just crushing it. Nate, did you get... I'm getting a lot better. Yeah, is it starting to make more sense on why we do the 2-sample t-test? You've got 2 groups. You want to compare the means between them. The null hypothesis for this is that the 2 groups have equal means. So you would assume that, like, I guess adults and children's cereal have the same amount of sugar, but you can reject that null pretty easily and say, yeah, there's a lot of evidence to conclude that that difference is not 0. Like, you're pretty... The difference we observed was 36 more grams of sugar. I'm pretty sure children's cereal has about 32 to 40 more grams of sugar on average than adult cereal. So I reject the value of 0. I do not think they average about a 0 difference. I think there is a much greater difference than 0. So understanding what we're doing right here when we compare 2 means and try to understand what the truth is for those 2 means. And this is what we saw in our sample. You might say, well, that's the difference, right? Well, that's just for our sample of cereals we took. We took a bunch of cereals and took samples. So understanding what we're doing is very important here to be like, when would we use this? Why do we use this? What does it mean? Another question throughout those questions. Great job. Nate, thank you so much. Excellent questions. A quick question about having done poorly on math exams. Let's do it. Is that the traditional, non-traditional question, Robert? Is that the traditional learning question? Which one is that? The that's the July-August one, right? That's the quiz, right? Of course. Got more than enough time. Yeah. Thank you, Robert. Keep asking those questions. We're just here in free question time. So yeah, ask the questions. Be like, hey Brian, can you work this one? And then we just do it next. And don't worry if I'm doing a question. If anyone's watching right now and you have a question, just put the question out there. We try to do them in the order we get them. So the sooner you ask a question, there we go. We got the question up and loaded. So if I'm working a question right now, you bet, Robert, it's got 4 answers. Well, let's do it. So if I'm working a question, just say, hey, Brian, can you work this? And we'll work it. Let's go check out having done poorly. Here we go. So this one right here is a bit of an interesting question. We need to review our conditions. Condition 1, I'll tell you the rest if you just tell me condition 1. You know what condition 1 is. What do we need to do for our samples right here? Are you on Discord or anything? Can you send me the data like in an Excel file? I'll run it for you. Why not? Yeah, we'll do route A, route B next, Grayson. You got it. Thank you for asking it. What is condition 1 for any time we use data? No one forgets condition 1. No one. Not a single person in the history of forever has ever forgot. Or maybe people have. You see Brian like reach over. Whew. Condition 1 is what? Never gets old. Condition 1 is random. Great job right there, Robert. So random, condition 1, we randomly select these individuals. Condition 2, 10%. And then we have to pause because it matters what kind of data we're collecting. These are test scores. Randomization / independence, it's sometimes called. It's that the data is randomly sampled. Does that make sense there, Robert? Is that these are random students in the June, like we randomly take students for a June group. We randomly take students for an August group, which we're going to see some issues with this later on. But they'd be random students. Like we're not going to pick the first 5 students we talked to, first 6 students we talked to. We're trying to see if there is a difference right here between the groups, and there'd be random students picked for each group. So we randomly pick students. We pick less than 10% of all students. Now we have to pause and slow our minds down after random 10%. And then we have to ask ourselves, is it quantitative or categorical? One letter in the chat to help me out here. Is somebody's score on the test quantitative or categorical? Is somebody's score on a test quantitative or categorical? We're on here to the following condition, which if I show you, is somebody's score on a test quantitative or categorical? It's quantitative. That means we need to do the nearly normal. If it was categorical, we would do success failure. Nearly normal means the distribution needs to be somewhat normal. Longer talks on this could be had, but let's say it's a very small sample size. I don't see any extreme outliers, so maybe it's good. I don't see any extreme outliers. But the last condition is where the problem is going to arise for this question. For the last condition, the groups need to be what of each other? And I want you to say the word just so you remember it, and I'll tell you the answer here in a second. The last condition is that the groups need to be what of each other? And I'll explain what this means. The groups need to be what of each other? Now, when you do the independence mean test to test to see if means we're testing 2 independent means and to see if there is a difference between them, the groups need to be what of each other? Independent. Robert, great job right there. So what does it mean that groups are independent? Well, let's say you want to know how much money Brian spends on groceries a week versus how much money Brian's brother spends on groceries a week. Well, you've got Brian's spending on groceries a week and Darren's spending on groceries a week. Do you think I call up my brother and say, hey, Darren, I just spent so much money on groceries. You should spend money too. No. Darren's spending on groceries is independent of what Brian spends. Does that make sense to say it's independent? Like if you know how much Darren spent this week on groceries, it's not going to dictate how much Brian spends. But in this instance, we have students retaking a test. So this is a certain student right here who did kind of all right in June. I mean, that's not the worst. 68 is not horrible. I mean, I got a lot of 68s. So, and then look right here, they made a 74 in August. Good job, they did better. And this student, this is a certain student, did a 54, and so this student did worse. So if a student did worse in June, would that tell you anything about how might they do in August when they retake the test? A certain student, the same student, taking a test in June and then taking the same test again in August, would you know anything that if they did worse in June, would that tell you anything about how they might do in August? Would that give you any sort of information? What do you think? Oh, Ben, what's up? I'm an analyst. Yes. Yes. No, we've been meaning to, actually, it's a huge talk. There are courses, IMNT 341, 342 do SQL, and we've actually been talking about incorporating more SQL. And Ben, talk to us more about this because Ben, thank you so much, Call Me God. I appreciate that. No, we need more SQL. We need more SQL. No, database management, SQL stuff is really great. And IMNT 341, 342 are excellent classes on that. And we have a lot of talks about how we should start incorporating more and more SQL. I almost wish we put some in Stat 201. And so here's the thing. And Ben, congratulations. Hope that interview went well. 100 points for Ben right there. And so good to see you again, Ben. I saw the name. I was like, I haven't seen that name in a while. So if we knew how a student did in June, that would give us information of how they did in August. So guess what? That means the two groups, where is it? The before and after scores are not independent samples. This violates the independent groups. So we don't have we have a before and after. So if you know how someone did in June, that would give you information of how they did in August. So does not meet the independent groups. So we can't use the tools and techniques we've been learning in this chapter. Great work right there, Ben. Tell me more about that. Ben, did you take the course a year ago? We got a lot of new stuff. We got so many new things here, Ben. So many new things on Stat 201.
I am Mubot.
Got Mubot around these days. I made that effect, so I gotta overuse it. Every once in a while, every 2 weeks, we pull out that effect. Let's get the next question going right here. Buttons I don't press normally. Maybe I should. Next question getting up and going. It's what I do when I have a break as I start working on random effect. Oh, the random? That's from Jason. And then I put it into a video because he made it like its own video. Can't remember how we used it. Stranger Thing intro. Oh, we still got Stranger Thing info. Smash Bros. Brian. I love it. There's things I don't use that much. Look, I'm not positioned right on this today. God, this is what I'm actually... This is like with the green screen off right here. This is the no green screen effect right here when I'm just sitting with my guitars back there. 4-string guitars. Get the man moves to a new city question going up here. Yeah. Yeah, IMNT 342, 341, I believe so. I play all these guitars. Every single one of them. Every day. Trying to think what else I have that I like never use as stuff. I don't think this has much on here that we could do. Davey504 would be very angry with me. Let's head back to the main screen. Here we go. Man moves to a new city. Let's do this right here. Here we go. Totally where I'm actually at right there. Okay. Davey504 did a video where he appeared in his chair, and I was like, I could take that right there and use the background. It's fun stuff. Find a 95% confidence interval for the difference in times between the man's route for route B and for route A. Now, a lot of people have used, because I've done this in another video, and don't worry about it, but follow through all the steps, because I think a lot of people take my my T-score and they use that without doing the steps. This one requires a lot more work than it would seem, because there's a lot of equations we have to solve for this. So we need to go inside of here, and we need to take the information, of course, bring it over to a Word doc. I've started doing this again because Epic Pen's being a little bit weird on my computer. And we're going to go right here with the Word doc. The update Microsoft Word made it look different. And so now we're going to take the information inside of here, and we're going to compare the what's between the routes. The whole goal of this is to compare the what's for each route. Like, what are we doing with the two-sample t-test? What's the point of a two-sample t-test? We have route B, we have route A. Do you remember if you've done the question about spending more time? We can do store-based array differences. Yeah. We're open questions after this. Thank you, Grayson, right there for asking. Oh, we want to compare the means. Exactly. So this would be right here. I'm going to do a different color. Great job right there. This is the mean for B. That's sample mean for B. This is sample mean for A. And then we have the standard deviation for A. And we have the standard deviation for B. Marking your notation is key to any of these problems. And then we have the sample size right here. So this is n sub A and n sub B, being that he rides each route 20 times. Be careful, your question might be different in many ways. So now we need to create a confidence interval for the difference. And this is where people usually, I've had a few people solving this and they use my numbers, especially with the t statistic. Your t will be different because this t is based on the degrees of freedom via the t calculator. Does anyone know how to put the t calculator on the screen? Ask MuBot to show you the t calculator. He will. S sub 1 squared. My phone's buzzing. So we're going to go right here. Let me grab the t calculator. T, or degrees of freedom. So we see right here that each route is rode 20 times. He rides each route 20 times. So he's going to bike 20 days on one route, 20 days on another route, flip a coin to figure out which route he's biking. And then we have here 3 for the standard deviation of one route and 5 for the standard deviation of another. So we have to put this information in and go to the t calculators on the screen right there for you, in the chat. Check it out. I think it was 3 and 5, right? I made a mistake one time. 31.11 degrees of freedom. So what's the point of this? The degrees of freedom tell us the what of the t distribution. 5-letter word tells us the what of the t distribution. If you know the degrees of freedom, you know which particular t you are using because every t has a different shape to it. You have to put in the degrees of freedom because it will control the shape. Notice how it changes when I change the degrees of freedom. It looks different each time. So you need to input your degrees of freedom, and I would round it because I think the applet prefers that. So now I'm making a 95% confidence interval, and I want to show this. This is the same 5% outside. You see the 2.04 for the t, as if I do 95% inside. So the 95% confidence interval has a t-score of 2.04. Now that's close to 2. Won't be exactly 2 a lot of times. It can be exactly very close to 2 if you have like 60 degrees of freedom, which we don't. But with 31 degrees of freedom, we get 2.04. All of this work right here, what you need to do is to find this value right here, and that's the only value we were missing. This value of the t star. Yeah, exactly. For this one, we would. The 2 sample t, great question right there, Robert. The 2 sample t has a complicated formula we don't solve. I keep saying that. 2 seconds, watch this. I'll go show you it. I'm not going to write it down. One of these days I'll memorize it. 2 sample t degrees of freedom. It would just be like a bunch of work if we had you solve this. Like if we were like, here, solve the 2 sample t degrees of freedom, it would just be way too much work. So the applet is solving. 2 seconds. Here is what. Oh my gosh, that looks ridiculous. I'll put it on the screen like this. So the applet is solving this right here. This equation is what is being solved for you. S sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2, square that. 1 over n minus 1, 1. How would you identify in a world problem? Email. Tell me if you email me it or Discord it to me. Email it or Discord it to me. How would we identify it in a world? Oh, in a word problem. How would we identify it in a word problem? We would tell you the degrees of freedom, but this one right here is a 2 sample t because we have 2 groups. When else have we talked about degrees of freedom? Real quick question right here. We talked about degrees of freedom already where we did 1 group. And what was the formula for a 1 sample t degrees of freedom? Which that one you may have to solve for. And hopefully you'd be like, yes. Like if I go over here to jump, kind of a quick problem right here, and I analyze the distribution of children's cereal, and I do a 1 sample t test on this. I'm not doing adult versus children's cereal. How could I know the degrees of freedom? And I can tell you the degrees of freedom by looking at this. Can you tell me the degrees of freedom on this? So how would I know the degrees of freedom for a one sample t? The one sample t degrees of freedom where you're testing one mean. Awesome, Nate. I'll check that next. Great job, Nate. The one sample t degrees of freedom are just what? Easy formula to solve. Like you get that on test, you're like one sample t degrees of freedom. Got it. N minus one. So there it is right there. And the two sample t's, the more complicated. Yep. You probably did. I'll check it out in a moment here and we'll see. So then we'll walk through the steps and I'll make sure you see some answers. I'll let you decipher the answers as I do the button clicks. So the two sample t you will not solve. You will not solve the degrees of freedom. And that's just to get the t statistic that creates the 95% confidence interval. And now we need to plug in the remaining numbers. Make sure to plug them in correctly or you'll get an error like I have gotten every once in a while. This is mean 1 right here, which is 51. Mean 2, which is 50. Standard deviation, these don't matter which order they go in because they both have the same sample size. So we'll put 3 right here and 5 right there. That's 25, 9, 34, 34 over 20. 34 over 20 is that square root. And we just solved for the standard error. Times the standard error by 2.04. And we have the what now? What have I found? Tell me mathematically. I'm showing it to you on the screen. What have I found right here? What is that? I solved all the mathematics and I solved for this. I've just found the two-letter word. The standard error times the t is the what? So this, I just solved everything from here over. What did I just solve for? I just found the what of the interval. So I found all of this. That's the mathematics for everything after the plus or minus. It does matter which way you subtract. It does matter. The way they do the interval, Grayson, great question. You have to do B minus A. It's the way they compute the interval. Such a great question right there. 100 points, Grayson. They compute the interval B minus A. So make sure to do B minus A. Margin of error, another 100 points right there. You have to do B minus A. So make sure it's the way they compute it every time. If it's not back up by tonight, and I might even extend it. Cora probably will extend it. A lot of people have been reporting problems today. So when there's a general outage, like if one person has a problem, I'm usually, I hate being mean, but we have a lot of students. So, but I feel like I feel like we're leaning towards an extension, especially people have been saying that there's a problem. And thank you, Cora, for reporting that. 100 points, Cora. So all we're going to do right here now is take the value. And this is 1. Does that make sense how this is 1? 51 minus 50 is 1. So let's write it. I think it was 2.66 amount. Does it round 2.66? It does. And so that's going to be that. And so 1 minus this. So that's negative. 2 decimals, good. And then 1 plus this. 3.6. I got it on my head. Should we believe the claim of 5 minutes? Do you think we should believe the claim of 5 minutes? Do you think we should believe? Message me on that too, Cora. I'll check it out. Do you think we should believe the claim of 5 minutes or nah, I don't know about that 5-minute claim. What do you think about that 5-minute claim? Like, he's like, Route A is about 5 minutes faster. And you're like, well, I'm saving about a minute. Nah, I don't know about that. Because I think the difference is somewhere between 1 and 2/3 minute with A taking longer or B taking longer by this much. It's not in the interval. No, because it's not in the interval. We would reject that difference. Woo! Getting scared right there. Let me go look at Nate's question right here with the output. Let's go take a look. I'm going to go back here to this music. Let's go look at some output. Canvas, internet. We love you, internet, but internet, what do you do to us? Why, internet, why? So Nate, I'm going to, since mostly it's button clicks, I'm going to run the output for you, but I'm not going to tell you the answer. Okay. What is going on? Yeah, we're seeing a lot of Canvas issues. Right now, my email has a lot of Canvas. We're getting near the triple digits. Woo! Yay, Canvas. Thank you for dying on me. I'll never let go, Canvas. Never let go, Canvas. Never. Don't let go. Go. Let's go ahead and take a look at this right here. Here we go. All right, so I've got your data right here. Should be the right data. We're going to go here to analyze fit y by x. Go here to table stack. We'll go over here. Go to analyze fit y by x. Put the label in. Put the data in. Nate, what do you want me to run right now? I got 2 groups right here. How would you like me to compare those means right here, Nate? We're 1 click away, Nate. I just need to know what statistical test to run to compare these 2 groups. To compare the means of the 2 groups. Nate, if you can tell me what statistical test to run, we will get this output. And we will know some answers. What test should we run on this? It's 2 groups. 2... Close. 2 sample t-test. 2 sample. Which does have 2 variables. It is a quantitative y with a categorical x. And it is called the 2 sample t-test. It's a type of t-test. And 2 samples. Shivam, definitely. I think, was someone else asking about that? Totally fine. 100 points right there. Andrew and Nate helping each other out. And there is the stuff. I'll let you kind of go from here, Nate. Do you know what to do with this output from here? Like maybe pause the screen or take a screenshot of the screen. But this is the analysis of your data right here. And I am shocked to find out that children's cereal has more sugar content than adult cereal. But how you doing on this info right here, Nate? Does that look pretty good? And you're like, good from there. Because I think you should, if you know the steps now, to be like, okay, this is what the output's telling me. This is where I need to look. Yeah. Tell me if you have any issues with the question. I think the output now, as long as you know how to interpret it, you should be good for the question. Now that the analysis has been completed right here with the confidence roll and the 2 sample t-test, should be pretty clear on what the results mean. You can also see what the output looks like. I'm going to do the next question here. I think, did we have one right before we got the glass question, and then we got store A, store B. Let's do it. We got store A, store B, and then the glass question. Store A, store B. Hearing weird noises. Store A, store B question, and then the glass question. No. Yeah, it looks like. You know what I might do? I should get some... I have an idea. I'm just watching myself in the mirror now. Not in the mirror, but... I have an idea that I'm going to do. That'll be really nice. More on that later. Okay. Store A, store B. Brian thinking face. Store A, store B. Let's do it. Let's compare what people spend at the store and let's wake up. Coffee's wearing off. Oh, yeah, we're good. We have here consumers going to store A or store B. We have 80 visits to store A, 79 visits to store B. On average, the amount spent at store A was $44. On average, the amount spent at store B was $53. And we also see here a standard deviation at store A of $20 and a standard deviation of store B at $18. So what do we got going on right here? Well, good news, they give us the degrees of freedom. Super duper nice of them. And let's run the test right here. Identify the null hypothesis. They're asking, do customers spend more on a trip to store A or store B? What sign does the null always have, which helps us eliminate things down? What sign does the null have? Just drop it there in the chat. Jessica in the Discord. Yes, yeah. I was thinking, has the equals. So we're asking, is there a difference? And the alternative would be there is a difference. So this is the difference between the stores is equal to 0. And the alternative would be it's not equal to 0. Now, the test statistics where it's going to take a little bit of work for this test statistic. Let's go grab the data right here. And we need to... Said I should not drink a third cup of coffee. My brain said, Cora, great job right there, and Andrew, good practice. My brain was like, you should drink a third cup of coffee. And then my logical brain said, Brian, don't do that. Don't you drink that third cup of coffee. Your body's, don't do it. Don't you do it. Don't drink that third cup of coffee. Okay. Let's go right here and run the statistical test. We have pretty much everything we need. except for, well, no, we have everything we need almost. To run the statistical test, we're going to do y bar a. Let's look at how it's written. Just want to make sure. Yep. It's a minus b, so we have to run the test that way. Double check your way it's written. Some of them do it differently. And then we do square root s sub 1 squared over n sub 2. Does anyone know the name for this for 100 points in the chat? What is the bottom of this equation called? It's the what of the two means. The what of the difference between the two means. You can just put two letters. I'll know what you're talking about. The bottom of that equation is called the what. What is that bottom of that equation called again? Right there, something. The bottom of that equation is called the what between the two means. It's like it's a measure of variation that we use to standardize differences. So the bottom of that equation is called a what for the difference between the means. Let's see if someone gets in the chat. So we're just going to plug in our numbers right here. Plugging in the numbers, solving out the equation, putting in the first mean right here. Ooh. I showed the answer on the screen there for a second. And s sub 1 squared, so 20 squared, that's 400. And divided by n, it's going to be 5, isn't it? Yes, Robert, good guess right there. It is the, I clicked the wrong button right there. It is the standard error. We call it a standard error because it's based on estimates, so it's the standard error. That right there is called the standard error. That is the standard error of the difference between the means. Yep. Great job, Robert. Don't worry if you even take a guess. I usually throw out points, but no, you got it right. It is called standard error. What is that going to be equal to? Brain's like almost doing it. So it's gonna be 324, I think 324. And so that's gonna be like 4-ish, something like that. So it's gonna be 9. It's gonna be 3. T is gonna be about 2.8, negative 2.8. I say a T of negative 2.8. That's my guesstimate of the T right there. It's a guess. Let's find out the answer to the T, what it actually is. Finding out right here, right now. Let's do this. So, yeah, it's going to be about 3.1, I think. Whatever. Let's do it. 20 times 20. 20 times 20 divided by 80 is 5. Good stuff. We knew that one. 80 times 18 divided by 79. Maybe I am very close. Square root. And 44 minus 53. Negative 2.98. Dang. Shit, I knew it would be close to that. I knew it would be close to 3. Negative 3. So negative 2.983. I think it's negative 2.98. Here's the thing, though. What is that super close to? When you think about the normal curve, that's basically, and this is a t-score, it's not quite a z-score, but it's basically that. What is that super close to? The t-score right here is negative. Be careful, it is negative. You could make a mistake and not do the negative. So the t-score there is negative 2.98. With a t-score like that, it's very close to negative 3, right? So here's the thing. Pretty sure we can guess the p-value. The p-value is going to be about, and that means we reject the null hypothesis. There is evidence that they're not equal. Now be very careful right here. I think we've done everything properly. Let's see if we're right. We got it. How did I know this? How did Brian figure this out without the applet? How in the world could I have figured out that p-value and gotten close enough without an applet? Well, what you need to do, what we should do if we're doing the step-by-step approach, is we have to go to the applet. And so the T's degrees of freedom are 155.67, like it would give to you on a test. And then we could show you a picture on the applet. So let's go to the applet right here, appearing in the chat from Mubot. And here is the T applet. 155.67 degrees of freedom, rounding up to 7 right there. And then our T statistic was 2.98. And actually, I got lucky enough that it gave me it. I was going to guess about 0.003. And the reason I was guessing about 0.003 was why. If you remember from the normal curve, I'm lucky it gave it to me. The normal curve, if you go outside of 3 and -3 on the normal curve, you get 0.003. So our number over here with 155 or so degrees of freedom and a t-score of -2.98 is basically the normal curve. I put a little bit extra on because we don't have a z-score of 3. And I am interested to know how exact this is because I'm going to go over here to R real quick. And I have to know. Nope, I want PT. And -2.983 or so. And 155 degrees of freedom times 2. And it is 0.003. I'm on a PC over there. And, I could be like boot camping, right? But no, it's 0.003. And it gave it to me because I was close enough. But we could have guesstimated from the empirical rule on the normal curve that, remember, outside of 3 and -3 is 0.003. And since our T has so many degrees of freedom, if the T has a lot of degrees of freedom, the T is basically the normal. After about 100, the differences are so minute. You still need to use the calculators to double check, but I just want to point out we were able to give a good estimate and say, well, the t-value is pretty large. P-value is going to be pretty small. We reject the null hypothesis. Good questions right there. We've got like 10 more minutes. Let's hop to the next question. I like taking guesses of them. It's a lot of things can be estimated in statistics if you understand, like, okay, a t is large. Like, just do this right here. 100 points in the chat. If that t-value had come out to be 8, what would you estimate the p-value to be? If the t-value was 8 for that test, what would you have said, Brian, the p-value is probably this? If the t statistic was 8, what would you tell me the p-value is? You just say it's basically this. You'd be like, well, it's basically this. 100 points in the chat. If the t-value had been 8, you'd say, yeah, this is basically this. You wouldn't go to an applet if you know statistics. You wouldn't be like, let's go look at the applet. Now, if you go to the applet that you don't know statistics, but if you got a t-score of 8 on that test, you'd be like, yeah, that's a p-value of this. That's going to be a certain p-value. What would it be? I think we've got the... Shivam had a question. We're going to do Shivam's question. Small glass, large glass. If the t was 8, what would the p-value have been for that? T of 8 is a pretty extreme value. So if we got a t of 8, what do you think? Ooh, wait, where'd the small glass, large glass go? How'd I miss it? Is it only on the homework? Here's small glass, large glass. Let's do this. No one knows the p-value. P-value would be 0, basically. Let's go check out small glass. Hey, Kayla, great to see you here. Awesome stuff. We'll be talking a lot more. I'm excited. I'll write Petri this weekend. Good stuff. Exciting stuff to come right here. Let's go check out large glass, small glass on step 1. Use the help function to explore with the series GAFA, Stock, PBS, and Vic. Yes, you're checking it out. And do you have the FPP3 library? Whoop. Yep, FPP3. Whoop. Type it in the chat. Install pack. Yes. You're looking at it's the Google, Amazon, Facebook, Alexa stock. I can't think of the other. Apple. I think it's Google, Apple, Facebook, Amazon. Ah, nice. Excellent work. Kayla working ahead right there. Excellent work. Excellent work. Kayla, I can give you some more resources too. Keep asking, and great work right there. Checking out the new code. Kayla is going to, and if you ever want to swing by our class, I can send you the link, or you want to see the new class. We had a really good competition last class. It was really awesome. Andrew can speak to it. It was pretty crazy. I'll probably do one more at the end of the semester. It was almost like a Kahoot, but people were answering on the Discord and just like firing off answers. It was really cool. So the mean for the two glasses is believed to be the same with the null hypothesis. That means we have the equal sign right here. I'm going to kind of work through this one and explain as we do it, because I'm going to grab some food in a second. And the mean for the other glass, we want to see. Yeah, it was a lot of fun. I hope today's class compares. We're going to talk about some advanced models today with like neural nets. People randomly given either this or... Kayla, are you free in 22 minutes? You want to come and speak to the class real quick? Did the size of the glass change? So that's going to be not equal. If you're free, which slides go over the Tibble? I don't know if I have slides on it. Let me. I can send you something. The Tizble. So different, not equal. Because we're seeing if there's a different amount. It just jumps right to the t-statistic now. So we're going to do the same sort of thing we just did a moment ago. We're going to take this, copy this, and bring this over to the equation. Ooh, this one's a little bit more work. So we're going back in time right here. I was going to have you talk to the class maybe about your research or stuff like that, or like your internship. Would you want to do that? You don't have to. You don't have to. Put you on the spot right here. But would you want to talk to them because you got an internship right out of time series? I got contacted by Patrick just randomly saying, do you have people who can do Shiny? And I was like, yeah. I got students who just were trained on Shiny. And yeah, like it was, I didn't plan on someone contacting me immediately and asking about an internship opportunity for my students. But that's exactly what happened. And it was the exact skills that people are learning. And then the company, you know, like, you can talk about your experiences or what. We could do a quick interview so people can hear about it. Because there's a lot of utilization in what we're learning. And that's my goal right here. Mean 1 versus mean 2, where mean 1 is the small glass. Mean 2 is the large glass. Okay, mean 1 is small glass. It goes in order. I don't want to make any errors. We've gone error-free for a while. We're taking the small glass is mean minus the large glass is mean over. Don't worry, I'm putting you on the spot, I know. My phone blinking like crazy. Canvas is down. World's on fire. But how are you? That's what I say. Got 30 samples for both glasses. We don't square that. Don't square that. Don't square that. 30 samples for both glasses. And 4.8. Oh my gosh. 1.96. 1.96 right here. And good. 2.83. Yeah. Yeah, you don't have to talk specifics. We don't have to show we're not going to show anything. You don't have to talk specifics. If you would want to talk about like you don't have to talk specifics about what you're doing, obviously. But if you wanted to talk about just how, maybe to me, you've kind of shown a role model for how people can learn things and progress their knowledge, because especially with you going through and doing the assignments that we're doing in Force Indy 5 right now to do the new assignments, and you can see some of them are old repeat assignments from the summer, because it's hard to come up with all new assignments every semester. Like going through and learning the new things gives you new skills. And there's the T-score. Oh, man, we got a good T-score. Another one close to 3. Negative 2.94. Is this the one that wants ridiculous decimals? Sigh. If for some reason that's a 5 right there. Does it say that 5? I'll Discord you, and if you want, no pressure. I won't. I'll be totally fine if you say you're busy or you prefer not to. That's totally fine. Negative 2.943. Negative 2.943. Now this is the ridiculous one, and we have to go to the degrees of freedom calculator to get the proper degrees of freedom. So the degrees of freedom calculator, this is usually where the mistake occurs for a lot of students. The degrees of freedom calculator is used to find out which T we are using. So we have to put in the sample sizes, 30 for each group. And then we have to put in the standard deviations, 1.96, 2.83. You don't have to have the same sample sizes, but you might. We're going to round up to 52 degrees of freedom when we put this into the applet over here. 52. I'm going to put both these in the chat. The degrees of freedom calculator is currently in the chat. And then I'm going to put the T distribution once MuBot says the degrees of freedom calculator I just used. So those will be in the chat. MuBot should tell us about those. So now we need to put in the T statistic right here. That's not the T we found. Oh, no, there's the degrees of freedom, right? Make sure it's the same degrees of freedom, 52. Round it up, because this one takes a rounded. And here's my concern. Always my concern with this question. This applet doesn't let you enter in the decimals. See, if your decimal's off on this, just tell me. What are the degrees of freedom? I'm going to look at what I would have got without Brian's advanced way of doing it. So it's 0.0048, rounds to 0.0049. Now, that's the exact answer via like very fine calculations using software. You are not expected to do that. You would enter in, according to the applet, this. So this is what the applet is showing me right here. What? The applet is showing me... Did I delete off that answer? Oh, here it is. The applet is showing me this answer for the two-tailed test, 0.0050, because we can't see a last digit. That's what the applet is showing me. Now, that is a very small p-value, so I would reject the null. The data provide evidence that there is a different amount. Are we going to scream? Well, you know what? Let's get it right here first, and then let's see if we would have gotten it right without our advanced work. Let's get it right? Of course. And then let's put it in the way we would have put it in. Good. So we like to see, but please tell me if you're off by like a decimal. I've already corrected a few people's. Sometimes this question is just really mean, and I don't like that. It's got a little bit of leeway, but the 4 decimals is a bit ridiculous. We usually don't. It's 0.05. It's close enough. But yes, so once again, this was able to solve via the way we do it. I just wanted to go in here and make sure using statistical software that I got a very exact calculation, and I could even cheat. And this is what I love about stat software, is I could go here to round and ask it to round it to me 4 decimals, and I could zoom out really fast. Is what I could do. And I could get the answer like that. So now that's rounded to 4 decimals. I don't even have to worry about doing the rounding in my head. The software rounds it for me. And hello. Well, with that, hello and goodbye. We will see everyone soon here. Bye for now. Gonna grab some food.